NFPA 70, the National Electrical Code, in Section 501.10 addresses electrical equipment in Class 1, Division 1 locations. It states that all electrical equipment and wiring must be suitable for the class and group of the hazardous materials present. NFPA 30, the Flammable and Combustible Liquids Code, addresses flammable and combustible liquids. Section 9.7(1)(e) states that for hydrogen, a Division 2 classification extends 15 feet horizontally in all directions from the source. When interpreting these codes in a specific scenario where hydrogen is used in an area already rated Class 1, Division 1, Group D due to solvent vapors, several factors must be considered. Based on the information provided, the area where the hydrogen is used is technically rated as Class 1, Division 2, Group B. However, the presence of solvent vapors, which fall under Class 1, Division 1, Group D, dictates that the entire area be classified as Class 1, Division 1, Group D. This classification has significant implications for motor selection. Since the area is classified as Class 1, Division 1, Group D, and hydrogen is present, all electrical equipment, including motors, must be suitable for Class 1, Division 1, Group D service. The use of totally enclosed fan-cooled or TEFC motors is generally not sufficient in this scenario, as they are typically suitable for Class 1, Division 2, Group B or Group D service, depending on their rating. Therefore, several options can be considered to ensure code compliance and safe operation. One option is to use purged explosion-proof motors rated for Groups B, C, and D. These motors are specifically designed for Class 1, Division 1, Groups B, C, and D service. They provide the highest level of protection in hazardous environments where multiple gas groups are present. However, these motors can be significantly more expensive than other alternatives due to their specialized design and construction. Another option is to use explosion-proof motors rated for Group D. These motors are suitable for Class 1, Division 1, Group D service, addressing the risks posed by solvent vapors. However, they are not rated for Group B, which pertains to hydrogen. Given that the hydrogen process is already classified as Division 2, this option might be acceptable under certain conditions provided a thorough risk assessment is conducted and all safety measures are in place to mitigate the hydrogen-related risks. Enclosing the hydrogen system is another potential solution. By enclosing the hydrogen system in a separate, dedicated area that is classified as Class 1, Division 2, Group B, you could potentially use TEF motors within that enclosure. However, this approach may not be feasible or practical depending on the layout of the facility and the specific requirements of the hydrogen process. The selection of the most appropriate motor type depends on several factors, including the specific characteristics of the hazardous materials present, the classification of the area, the cost of the equipment, and the overall safety requirements of the installation. It's important to note that motors used in hazardous locations must meet stringent requirements to prevent explosions. Explosion-proof motors are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Purged and pressurized motors are designed to maintain a positive pressure of clean air or inert gas inside the motor enclosure, preventing hazardous gases from entering. In addition to motor selection, other electrical equipment in the hazardous location must also be suitable for the class, division, and group of the hazardous materials present. This includes lighting fixtures, wiring, conduit, and control panels. Proper installation and maintenance practices are essential to ensure the continued safety of the electrical equipment in hazardous locations. Regular inspections, testing, and maintenance should be performed to identify and address any potential hazards. Modifications or repairs to electrical equipment in hazardous locations should only be performed by qualified personnel who are familiar with the applicable codes and standards. When dealing with hazardous locations, it is crucial to consult with qualified professionals, adhere to relevant codes and standards, and prioritize safety in all aspects of the design, installation, and operation of electrical equipment. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations. Understanding and complying with these requirements is essential to prevent explosions and ensure the safety of personnel and property. Consider the following points in more detail. Firstly, understanding area classification is vital. Hazardous locations are classified based on the type of hazardous material present and the likelihood of its presence in ignitable concentrations. Class 1 locations involve flammable gases or vapors. Division 1 locations are those where ignitable concentrations of hazardous materials are likely to exist under normal operating conditions, or where frequent maintenance or repair operations or leakage may release ignitable concentrations. Division 2 locations are those where ignitable concentrations of hazardous materials are not likely to exist under normal operating conditions. However, they may become present accidentally. Groups are subdivisions within the classes that categorize hazardous materials based on their ignition temperature and explosion pressure. Common groups include Group acetylene, Group B hydrogen, Group C ethylene, and Group D propane. Secondly, motor enclosure types play a critical role. The type of motor enclosure is crucial for ensuring safety in hazardous locations. Explosion-proof motors are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. These motors are typically used in Class 1, Division 1 locations. Purged and pressurized motors are designed to maintain a positive pressure of clean air or inert gas inside the motor enclosure, preventing hazardous gases from entering. These motors can be used in Class 1, Division 1 locations when properly designed and installed. Totally enclosed fan-cooled, or TEFC motors are not typically suitable for Class 1, Division 1 locations as they are not designed to contain an internal explosion. However, they may be suitable for Class 1, Division 2 locations under certain conditions. Thirdly, code compliance and standards are key. Compliance with applicable codes and standards is essential for ensuring safety in hazardous locations. NFPA 70, the National Electrical Code, provides detailed requirements for electrical installations in hazardous locations. Other relevant standards include NFPA 496, Standard for Purged and Pressurized Enclosures for Electrical Equipment, and ISA 12.12.1, Non-Incentive Electrical Equipment for Use in Class I and Roman II, Division 2 and Class Roman III, Divisions 1 and 2 hazardous classified locations. Fourthly, installation and maintenance require careful attention. Proper installation and maintenance practices are critical for maintaining the safety of electrical equipment in hazardous locations. All electrical equipment must be installed in accordance with the manufacturer's instructions and applicable codes and standards. Regular inspections and maintenance should be performed to identify and address any potential hazards. Modifications or repairs to electrical equipment in hazardous locations should only be performed by qualified personnel who are familiar with the applicable codes and standards. Fifthly, risk assessment is important. A thorough risk assessment should be conducted to identify potential hazards and evaluate the likelihood and consequences of an explosion. The risk assessment should consider all relevant factors, including the properties of the hazardous materials present, the operating conditions of the equipment, and the potential sources of ignition. The results of the risk assessment should be used to select the appropriate electrical equipment and implement appropriate safety measures. Sixthly, documentation is important. Maintain detailed documentation of all electrical equipment installed in hazardous locations, including the manufacturer's specifications, installation records, and maintenance records. This documentation can be invaluable for troubleshooting problems and ensuring continued compliance with applicable codes and standards. Seventhly, personnel training is important. Provide adequate training to all personnel who work in or around hazardous locations. Training should cover the hazards associated with hazardous materials, the proper use of electrical equipment, and the applicable safety procedures. Eighthly, consider intrinsically safe systems. Intrinsically safe systems are designed to limit the amount of energy available in a circuit to a level that is too low to ignite a hazardous atmosphere. Systems can be used in Class 1, Division 1 and Division 2 locations. The use of systems can significantly reduce the risk of explosion in hazardous locations. Ninthly, conduct regular audits. Conduct regular audits of electrical installations in hazardous locations to ensure continued compliance with applicable codes and standards. The audit should be performed by qualified personnel who are familiar with the requirements for hazardous locations. 10thly, stay updated with revisions. Stay up to date with the latest revisions to applicable codes and standards. The requirements for hazardous locations are constantly evolving, so it is important to stay informed of the latest changes. Regarding the specific scenario, given that the area is classified as Class 1, Division 1, Group D due to the presence of solvent vapors, and hydrogen is also present, the most conservative approach would be to use purged explosion-proof motors rated for Groups B, C, and D. This approach would provide the highest level of protection and ensure compliance with the most stringent requirements. However, if a thorough risk assessment indicates that the risk of explosion due to hydrogen is lower, it may be acceptable to use explosion-proof motors rated for Group D, provided that appropriate safety measures are in place to mitigate the hydrogen-related risks. The decision of whether to keep the existing explosion-proof Group C and D motors depends on a comprehensive risk assessment that considers the likelihood and consequences of a hydrogen explosion, as well as any applicable codes and standards. If the risk assessment concludes that the existing motors provide an adequate level of protection, and the installation complies with all applicable codes and standards, it may be acceptable to keep them in place. However, if the risk assessment identifies a significant risk of explosion, or if the installation does not comply with applicable codes and standards, it will be necessary to upgrade the motors to explosion-proof Group B, C, and D motors. It is always recommended to consult with a qualified electrical engineer who is familiar with hazardous location requirements to determine the most appropriate solution for the specific application. Remember that safety is paramount when dealing with hazardous locations. Always err on the side of caution and take all necessary precautions to prevent explosions and ensure the safety of personnel and property. This includes implementing a comprehensive safety program that includes regular training, inspections, and maintenance, as well as strict adherence to applicable codes and standards. By following these guidelines, you can help to ensure the safe and reliable operation of electrical equipment in hazardous locations.